All right. Okay, so in example 1, geometric sequence, it tells us A1 is 72. It tells us in R, that R, again, is called the common ratio.
Where are we?
It usually starts like...
So what I said was at the top of the guided notes, I left a big blank space. This is that extra stuff just to kind of review and define a few things. So in a geometric sequence, we're going to multiply by that amount. So we started with 72. If you multiply by 0.75, you get 54. If you multiply by 0.75, okay, so you see the pattern there. In example 2, our pattern would continue. We would have 1/6, 1/7, all the way up to whatever it is we're trying to find. So it says, and of course it could be huge, right? Or really small, I should say. So whose nth term, a sub n, is 1 over n. So don't forget, something like this, in your calculator, you might see it like this, right? That's the same thing as saying 1 times 10 to the negative 5. Okay? But you could see that this value, if we connected the dots, as we follow along, we're getting smaller and smaller and smaller. Okay? And that's something, have you ever heard the word limit before? So it could be something like the limit as this function approaches infinity. So as it's going, as x is getting larger and larger and larger, what is the graph going towards? A value of 0. Okay, so the limit as n approaches infinity of our graph, which is actually limit as n approaches infinity of 1 over n is going to be 0. Okay?
Will it ever reach the value of 0?
Nope.
Well, it doesn't exist,
The limit, well, the limit is going, it's, the whole definition of limit is what it's tending towards.
Okay.
So it will never actually be 0, but it does have a limit of 0. Okay. What's that? This is not. This is what I'm reviewing for up here. 0 is called the limit of the terms in this sequence. So, there it is. The limit as n approaches infinity of 1 over n is equal to 0. Infinity is the symbol for infinity. I'm glad we got that all cleared and straightened out. Okay, so, sure. What this page is trying to show is that if you have the limit of a sum, if you're taking the limit of something plus something, you can actually split it if it's easier to figure out what the limit is. Same thing with differences, you can write them separately. When you multiply, same idea, just you would multiply the limit of each one, and same with the quotient, okay? But of course, we have to pay attention that that denominator does not equal 0. So let's take a look at this one down here. The limit as n approaches infinity of 1 over n. This was the one that we looked at before, that we saw that it tends to 0. Well, this one goes a little bit further, and it now is raising that nth power to, that n to a power of r. All right, and if it's greater than 0, then the limit is still going to be 0. So anyway, we'll look at graphs and pictures of this and it'll make a lot more sense. But for example, if you have the limit as n approaches infinity of 1 over n squared, we know the limit of 1 over n is equal to 0. The limit of 1 over n squared is also going to go to 0 because n times n is just as large as n as we're going to infinity, right? Okay, so estimate the limit of 9 over 5, 16 over 4. So it gives us this sequence, and it gives us our nth term, which is helpful. So we want to know the limit as n approaches infinity of, and we could say 7n squared plus 2 over 2n squared plus 3n. And what might be helpful just to kind of have an idea of what's going on is to choose values for n. So let's let n equal 50, and then let's let n equal 100, and then let's let n equal 100,000. And tell me what we get for our function.
Do you always do n? Do you always do 50, 100, and then?
Well, we're trying to find what the limit is as it, we want to know what it is as it's approaching infinity. So I'm trying to find a pattern or something that it's tending towards, right? So if you start with a smaller amount and you go to a greater amount, you're going to have a good idea of what's going on. So in this case, if we do 100, so, all right, so this one is 3.3984. This one, if we continue down, right, to 100, we get 3.4484. If we continue with 100,000, we get 3.4999. So if you had to guess the limit, you could say the limit as n approaches infinity of your function is going to be what?
3.5.
3.5. Right? It's getting closer and closer to that 3.5 value. How much do you remember from your asymptotes, your horizontal asymptotes? So if you look at this, here's another way of doing it. If you're looking at your function, if I were to ask you where the horizontal asymptote is, what would you tell me? I don't know because I don't remember that rule.
I don't know because I don't know.
Yeah, so you're going to look at your leading values, okay? So in this case, n squared is my greatest exponent. So I'm really just paying attention to this. Because these exponents are the same, my horizontal asymptote is going to be at the coefficient of those values, 7 over 2. And what is 7 over 2? 3.5. Ah. So in fact, if you look at a graph of this, you'll see that your graph is going to tend towards that 3.5 value because there's an asymptote there. Okay? You can in a lot of the cases when there's a horizontal asymptote especially. So, but it's just something to keep in mind. Yeah, you don't have to plug in values each time to figure it out. You can look at a graph and see what's going on. Okay? Example 2. Okay, so example 2, find each limit. The limit as n approaches infinity of blah, 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 blah. It's a real math term. So same idea here. We can use those limit rules to split them up, right? So I can say, I can say the limit as n approaches infinity of 1 over n squared plus the limit as n approaches infinity of 3n squared over n squared. So in this first one is what we actually found before, right? Remember what it was?
Choose any number, like can we use 10 for example?
You can, but you're going towards infinity, so you know you're wanting to eventually plug in a huge number, right? So if you're looking at that first one, you have 1 over a huge number. What's 1 over a huge number?
1 over that huge
Alright, so if you had 1 over 100, that's 1/100th, it's 0.01, right? So if I have 1 over a million, it's gonna be 0.000001.
Oh, so 0.
So it's, right, it's tending towards 0. Do you understand that? Okay, so this is definitely gonna be 0. Here, I can actually simplify this, right? My n squareds are gonna cancel out, and I'm left with 3. If I plug in infinity for n, what do I get?
4.
Hold on. So we said this first one is 0.
Oh, you mean just 3 over 1, right?
Right, so if I cancel out these n squares and I just have 3, I'm plugging in any value for n, does it change my number 3?
No.
No, so the limit's just going to be 3.
What about the 1 though?
It will, that limit's 0 though. Because it keeps on going higher and higher. Right? It's, that one's 0 because, like, if you, the bigger you make the number on the bottom.
Yeah, so for example, 1 over 10 is 0.1, 1 over 100 is 0.01, right? So if I have 1 over, I'm going to have,
Yeah.
right?
I don't know if you've ever noticed, but Miss Barheim, like.
Wait, hold on.
Just cancel out. What about that 1? Isn't it just 1 plus 3? Why is 0 plus 3?
What is the limit, what is 1 over n squared as our n values getting larger and larger and larger?
1.
No.
0.
It's
Oh, yeah, 0. Oh,
Right?
so that's why we made it 0.
Yeah. So this is an infinite value that we're plugging in here, so it's going to be 0.0000000 forever, and then at the very end of that one, so it's basically 0. Okay? And so if we're looking at the whole thing, we put the whole thing together, then 0 plus 3 is 3. So we could say the limit of this entire function is 3. Okay? If, we'll try another one. So if I have something like this, the easiest way to do something like this is to simplify it first by dividing the terms by the highest power. So for each one of these, what is our exponent with the highest power? N squared. So I'm going to actually do that with each one of these. Okay, so that gives me the limit.
So the highest power, it's n squared, it's not divided by 2? Yeah. So it's divided by n squared?
Yes. Divide the terms by the exponent with the highest power, I guess.
Why do you do that?
It's going to simplify the entire function so that we can easily find the limit.
Right.
Promise. You'll see. So if I do that, I have... so the reason why you do it is for this reason. So if I look at this, and I'm canceling out my terms, I have n squared over n cancels out. This simplifies to 1 over n, right? This simplifies to 4 over n squared. So right now on the numerator, I have this, right? In the denominator, I have 1 plus 1 over n squared. Everybody good with that?
Can you keep change like this?
We won't need to. Because... So if you look at what's going on here, let's see if we can plug in. Remember, for all of our limit rules, we can separate things out and look at it individually, right? So I can take the limit as n approaches infinity of 5. I could take the limit as n approaches infinity of 1 over n. I could do each one of these individually and then add it together and divide it, right? The reason why, Ted, it's worth dividing everything out is because now if you look at this, what is the limit as n approaches infinity of 5?
5.
5, right? So if it's a constant, think of it like this. If you were to graph 5, it just looks like this. forever, right? At the 5 level. So if I say my x is infinity, my graph is still going to be 5. All right?
But how does it make the other ones?
So this is why it makes it easier. So here, before, I had n over n squared. Now I have 1 over n.
And that's 0.
What is the, right, this
It's
is 0. What's
And then
this?
4.
Okay, 4 divided by
Whatever.
a huge number. So instead of 0.001, now I have 0.004.
So
So
it's
this
still
is
zero.
still going to be 0.
And then the bottom one's 0 too.
1 and 0, right?
Oh,
So
that's really easy.
anytime you have a number over a variable like that, it's 0. As long as you're going to positive infinity, right? So that's why we do it. It makes it a lot easier. So I can look at this and I know this is going to 5, this is going to 0, this is going to 0, this is going to 1, and this is going to 0. So I have 5 over 1. That's a horrible color I picked, sorry. It's really much darker on my iPad. So we're talking about the limit as n approaches infinity of 1 over n, right? Which would be 0,
Okay.
right? Are you okay with that?
Yeah, and is 1 over n always 0?
As long as we're talking about the limit as n approaches infinity, because it's like saying 1 over a billion, so 0.000001. So if it's 4 over a billion, it's going to be 0.00004. Still close to 0, right?
Okay.
Okay?
So the limit is 5.
So the limit is 5, yeah. All right, so for this last one, you want to try it on your own and then we'll come together? No, not ready yet?
I'm so confused.
Okay, okay.
For the asymptotes, do you need one in the...
So yeah, if you want to look at it like that, you're just going to pay attention to your greatest value, okay? So in this case, you're going to take your greatest exponent in the numerator and your greatest exponent in the denominator, and you can say the limit as n approaches infinity of 4n squared over 2n. I can reduce this, or yeah, or just 2n, right?
Can you do the other method where you just divide everything by n squared?
You can.
Okay.
So I'm going to do that next so that you could see that it's the same. So 2 times an infinite value is just going to be infinite. It's infinity times infinity. It's just getting larger, right?
So it'd be like 2 times infinity.
Mm-hmm.
So wouldn't that just be like 2 times infinity, not infinity times infinity?
So there's whole classes about this in college. It's called abstract algebra, and it's all about various levels of infinity and how infinity times infinity is a huge value of infinity. And so we're not going to get into it too much right now, but if you have an infinite amount and you're multiplying it by 2, it's still an infinite amount. Okay?
Yes. Yeah.
So that's essentially what we're saying.
Okay.
So if we wanted to do TED like that other method, so if we were to do it the other way, which would be to divide everything by n squared, then this would go towards 0. This reduces to, the 5n over n squared reduces to just 5 over n, right?
Which is still 0.
Which is still 0, good. And then this part right here, the n squareds cancel out.
Yeah.
So what is that going to be? 4, okay. And then this part back down here, 2 over n.
So it'd be 0?
So this goes to 0. So you have 4 over 0, which is undefined, okay? And when a limit goes to infinity, another way to say that is undefined or the limit does not exist.
Ah!
The limit does not exist. Everybody knows it from Mean Girls.
Infinity or undefined?
At this point, I don't think it matters. When you get into calculus and you start looking at what graphs are tending towards, your professor or whoever might want a positive infinity or a negative infinity as an answer. Sometimes you have you can approach limits from different sides, and sometimes it goes positive infinity and negative infinity at the same time, and that's when the limit really doesn't exist. Okay?
It didn't exist before, it really
Yeah, it
doesn't.
really doesn't exist now. So, but, yeah, so there's that. Okay. I don't see it, though, on here, do I?
Looks really complicated on this.
Yeah, I think we'll skip it for now. So we have the limit as n approaches infinity of 1 over 5 to the n. Okay? 5 to the n. If I'm plugging in something like 10 for that n.
It'd be like really big.
Really big already, right? Now I'm plugging in 100. Really, really, really big, because it's 5 times 5 times 5, right? So if I'm doing this an infinite amount of times, the denominator is going to go towards infinity. So I have 1 over an infinite amount, which is,
It just gets smaller, doesn't it?
yeah, 0.
The limit doesn't exist?
No, it goes towards 0.
So it's just 0.
Yeah,
Okay.
exactly. I know this is confusing because it's not like, I mean, I can show you a graph of the stuff. Maybe that would help. I don't know. But it's a little abstract anyway. So the limit as n approaches infinity of 5 minus n squared over 2n. Again, multiple ways of doing this. I could split it up. I could divide everything by n squared. I could look at my greatest exponent values. Divide it up? Yeah. Okay. So the limit as n approaches infinity of 5 over 2n minus the limit as n approaches infinity of n squared over n.
It's dying out there.
What is this first one going to be? That's a 5. Right, so this goes towards 0. This is just, if I simplify it, I have n, right? N squared over n is n.
So that's just infinity.
So, right, so that's going to be an infinite amount.
Would it be n squared over n squared?
N squared.
Don't you take the highest value and then divide it by all of them, so wouldn't it be n squared?
Okay, wait, so that's one method, but you said you wanted to split it up.
That's just where you take.
Right?
I thought you meant divide. Okay.
Oh,
Okay, yeah.
well, we can do that too.
Well, why
Get the
if
same
you're
answer
splitting
in
it
the
up?
end.
Why is it 5 over 2n and then negative, and then n squared over n? Wouldn't they both just be over n? Because then when you put them together, it's 2n.
Say that again.
Like when you split it up, you put 2n under one of them and n under the other. But
Oh, whoops.
isn't it just supposed to be over n?
It's supposed to be over 2n.
Oh, they're both over 2n?
Yeah, because I'm splitting this fraction here. I'm just expanding it. So 5 over 2n minus n squared over 2n. Just like if I had 1 plus 3 over 4, that's the same thing as saying 1/4 plus 3/4, right? So if that's the case, and I simplify my n, then I have n over 2, right? which really doesn't change anything anyway, because that's still going to go towards an infinite amount, right? So we have 0 minus infinity, which would give me negative infinity.
And you can write that as an answer?
Yeah. Yeah, it is totally valid to have infinity or negative infinity as your answer. If you look at this, this other example where we divided by our n squared, same thing. So this is going to go to 0. This is just 1. And this is 2 over n, right? So I have 0 minus 1 is 1 over, or negative 1, I should say, over an infinite amount, so negative infinity.
Would it be infinity or 0? Or the same, that would be the same thing in this case? Because if you have 2 over n, can't that be 0? Like,
Sorry, this, yeah, 2 over n is 0, yes. So this would be a negative infinite, a negative undefined amount, negative infinity. Yeah. Okay. Do you kind of have a better idea of what we're doing here? But, did I miss one? Okay, so the sum of an infinite geometric series, this is what we did the other day, right?